Hi, I'm Mr. V. Today's illustrative mathematics lesson is from Unit 1, the second half, which is on rigid transformations. And we're on lesson 20, which is transformations, transversals, and proof. Wow, there's a lot of trans things, aren't there? Transversal, transformation, translation. A transversal is just a fancy word for a line that crosses two or more lines. By the end of the lesson today, you should be able to say, I can prove alternate interior angles are congruent. I can prove corresponding angles are congruent. Now, we'll talk about what those mean in just a minute. You should try to do pages 3, 4, 5, and 6 on your own. There's these different figures, and you're supposed to figure out what the value of x is. And then on page 7, share your strategy for solving these. And you should pause this video to do that. I'm going to go right into them and talk about them. First of all, about the strategy. This is the last thing that you would come up with on page 7. There's a man named Mr. Wendry. He was a teacher where I used to teach in Westfield, Massachusetts. And he would say, let's take a line. If parallel lines, we've marked them with these arrows like this. And he says, let's do this where I have a line crossing these parallel lines. And how do you know which angles are congruent? Well, maybe they look close to the same. If you draw them like 90-degree angles, they would be really the same. And so let's not do that. Let's draw it a little bit more slanty. And now it might be a little bit more apparent. And what he would do for his strategy is he would draw these really, really slanty. And you can see this. They look the same. Which ones look the same? Well, these small ones here are acute, and they look the same. These look the same. And then you have some that are obtuse. They look the same. And if you were in an earlier grade, say a middle school, you would say, well, they look the same, and that's why they are the same. But we don't do that. So I'm on a videotapings, if you don't mind. So we don't do that. Instead, but this is a good starting point. So if you can say, well, I know the acute angles and I know the obtuse angles, and you could draw this line and exaggerate it to make sure that you know which ones are the same. A pink one and a blue one here are next to each other. They're not the same. One is acute and one is obtuse. What is the relationship between those two? Well, if you add them together, they're going to equal to 180 degrees. They make a straight angle around that point. So this would be 180 degrees. One is obtuse, one is acute. Now, the more advanced way of looking at this is to talk about these two angles. We think that they're congruent because of our earlier grade way of looking at things. But if they're congruent, that means that the one object can be mapped onto the other with a set of rigid transformations. What rigid transformation would take 40 degrees to x? I think that these are the same. Let's just look at this. If I were to take this angle and I were to translate it by a directed line segment from this vertex down to this vertex, if I were to translate it, you can see that they're the same. Hey, this is 40 degrees. That works. Why? Because I translated by a directed line segment. Now notice when the words I'm using is the words I would like you to use. When you translate, you use a directed line segment from the one vertex to the other vertex. If I had them labeled, I would say from point A to point B. Here, well, these look like, maybe I translate this by directed line segment from the vertex to the vertex to get down to here. And then I rotate it 180 degrees around this point. That's one way of doing it. A different way would be to, and I'm talking about what transformation gets me from here to here. If I rotate it around this midpoint, this goes 180 degrees, right there. This goes 180 degrees. So I end up with the same angle. This is equal to 61. I can rotate this angle 180 degrees. And we'll see that later in today's lesson. Here, a lot of people wrote 98, and some people wrote 82. And which one is it? Why would you say that they're the same, 98, just because everything else has been the same up to this point? That doesn't make a lot of sense. I want to point out to you that this angle, 98, and this one right above it form a straight angle. They call that a straight angle. You could also know that it's equal to 180 degrees. Better do this in a darker color so you can see it. 180 degrees is what it equals to. That's this angle. Well, let's just call it x. Why would we call it x? Well, if I translate this straight up from here to here, it ends up being in the same location. And when you add x plus 98, you get equal to 180. So if I subtract 98 from both sides, I get x is equal to 82. And that's my answer. Finally, we have this one, 125. And I'm going to point out again that I could rotate it. I could translate it. I could translate it by the directed line segment from this vertex down to here, so it's there, and then rotate it 180 degrees. Or I could rotate it 180 degrees around this point. Any one of those will get me there to the same place. So basically, they're either the same or they add up to 180. They're supplementary. That's kind of interesting, isn't it? A little bit. Next, we have an activity that we did in class. When we translate, I'm not going to show the whole video, but this shows when I translate this, I go from A, B, C, D to A prime, B prime, C prime, D prime, E prime. Now, the little apostrophe there, that's the way we say that, A prime, B prime. And so if you translate, and the question is, what do you know about these two lines? And they are parallel. And the postulate, which is in your study guide, so if you, not your study guide, your reference table. If you look in your reference table, there's a statement here on page 2, I think it is. Translations take lines to parallel lines or to themselves. This is one that we did earlier on. And that's how I know that these two lines are parallel, because it's done with a translation. Translations take lines to parallel lines or to themselves. Now, we got into partners and we asked how would we name these? Name angles that are the same, and then explain why they are the same. And once again, I'm going to point out to you that if I were to use the middle school version of this, I could say, well, this angle is the same as this one. This one's the same as this one. Why? They all look the same. They're all acute, and they're parallel lines, and that. But in this grade, what I'm looking for you to say is to talk to me about what transformation would take angle BDE to our DBE, not BDE, angle DBE. You got to name them with the middle letter as the vertex. So that would be this angle. To angle B prime, I'm sorry, D prime, B prime, E prime, to say that these are congruent. And sure, they are congruent. They look, I've got the dots there to show that they're congruent. D prime, B prime, E prime. What transformation takes these to that? Well, this would be a translation. I could translate it. What would say that this angle is congruent to this one? I could translate it and then rotate it 180 degrees around point C. Do you get the idea? So we spent quite a bit of time on that. And then we looked at an alternate way of doing things, which is here. And this is, instead of translating it, we rotated it around point C. And I would do that. If I can do that now, let's see. If I rotate it, see if you can rotate. And you can watch the video and show us how it rotates it. So instead of being A, B, E, A prime, B prime, E prime, I get E prime, B prime, A prime. And D is down here because I rotated it around point C. What's true about these lines? Well, they are congruent. Rotations of 180 degrees take lines to parallel lines. Okay. And which angles are the same? Again, the same angles that you had marked before were the same, those ones that we marked in blue. But how did you get there? Well, maybe you rotated 180 degrees around point B. Maybe you rotated 180 degrees around point C. Maybe you translated and then rotated around point B prime. I don't know, but you need to explain to each other how you did this. Lesson synthesis. Now, this is where it gets a little bit hairy. I need to make sure I explain this correctly. We have an if-then statement. So if my lines are parallel, then, or if my lines are parallel, then the corresponding angles are congruent. If we switch those two arguments, if the corresponding angles are congruent, then the lines are parallel, That's called a converse. So if, for instance, in this first one, we start off with if the corresponding angles are congruent, well, we concluded then that the lines have to be parallel. And so we started off with the red, and we end up with this blue. The lines are parallel. Here we start off with the lines are parallel, then we can conclude that the corresponding angles are congruent. The corresponding angles, they're both in the upper right-hand corner. When we rotated them, we had alternate sides of the interior. We had this angle and this angle, alternate sides, and they're on the interior between the parallel lines. Those are alternate interior angles. That's the name of the relation. It's more important that you know the relationship, but later you also have to know the names of the relationship. Now, these two angles are corresponding angles. And the corresponding angles theorem says a transversal, that's the line that crosses two or more lines, a transversal crosses parallel lines to form congruent corresponding angles. So if the lines are parallel, then the corresponding angles are congruent. If you want the converse of that, you'll switch the arguments and say, if the angles are congruent, then the lines are parallel. All right. And so you might want to listen to this again and see if you understand it, how well you understand it. The last thing we do, these two statements need to find their way into your reference chart. The reference chart has them, but it's missing some words to make sure that you fill that in. And I would check it if we were in the brick and mortar, but I'm not going to check it, so it's up to you to do it. And finally, I have two videos to show you, two short videos, things that I made. A transversal crosses parallel lines to form congruent alternate interior angles, alternate sides of the transversal, interior between the two lines. This also works for alternate exterior angles, and I'm going to show you the corresponding angles portion of that on this video. So we rotate 180 degrees, and then I'm going to have corresponding angles by dragging it down. So a transversal crosses parallel lines to form congruent alternate exterior angles. Isn't that cool? And finally, we have the cool down, which says, I want you to show me how angles EBI and BCJ map one onto the other, because they're congruent. And then tell me, how does ABC map onto BCJ? And that should have been clear from the lesson earlier on how we would do that. Good luck and success.